Our next speaker, whose presentation is on fabric comfort, new research developments. And if I can introduce Dr. Yehia E, Mogahzy, who's presenting a paper together with Dr. Ramsis Farag, Dr. Ibrahim Hawary, and Dr. Faissal Abdelhady. Over to you, Dr. Mogahzy.
Assalamu alaikum. Or good evening. I guess I have to introduce myself. My name is Mogahzy. I came from Auburn University, U.S.A. in Alabama. Like this, if you've been in Egypt for the last 5-6 days, you must know that I'm Egyptian. At least by face, nature. I have been in the United States for the last 23 years. Graduated from North Carolina State University, and joined Auburn University. Been working there for the last 17 years, which is a long period of time. I enjoyed it very much, and I'm really happy to be here. And I think that's more than enough to get to the subject. The discussion, I think we asked you to keep the microphone far away so we can. Discussion is about fabric comfort in research development. This is a project that amounts to about $1.2 million over a good period of time, almost 5 years. And we are now in the second year. It's a joint project that involves 4 universities: Auburn University, North Carolina State University, Kilinc, and Georgia Tech. And we have also associates from California Davis working on the governance and multi-scan activities of this. So what I will do here is quickly, I will give you a quick idea about the concept because the time will not allow me to cover, of course, most of what we have done. But just the concept will be more than enough, and if you need any more information, the paper, hopefully it's in the CD, has more information. In fact, this presentation here is complementary to the paper that we have in the CD. It's not exactly the same material, but it's very much the concept I cover here. I'm using the wrong mouse. In the era that we live in, the information era of globalization and information technology, consumers are rapidly becoming information conscious. The primary key to competitive advantage would be to provide products that are information differentials. Many consumer products will move from the retail store shelves to thousands of websites that the consumer can browse through in a matter of seconds. It's inevitable that the whole market will move largely into the web page. The traditional intimacy with consumer products, food and textiles, for example, by handle, taste, and feeling, will eventually, at least partially, give way to ways of judgment via precise, reliable, and accurate and attractive information that will continuously aim at drawing the consumer's attention to the product. Well, in the textile apparel home product market, the most important information that the consumer would need would be fashion and comfort. Fashion, I think, is a challenge that has been overcome greatly over the last few years because via the internet, fashion can be demonstrated through many channels and many techniques, body scan, fashion modeling simulation, and even digital or video-based fashion shows. And of course, I'm not fashion expert, so I'm sure the people in fashion will know even more techniques than these. The true challenge is comfort. How can you translate comfort to people that have no intimacy with the fabric? Right now, we judge comfort in a very subjective way. My mother, my sister, my wife, we go to the store, and we have a very good feeling, and believe me, you need to trust their judgment. The challenge is not their judgment, The challenge is how to translate this subjective judgment into technical information that we can use in the fiber, the yarn, the fabric, and the garment manufacturing that can make fabric by design rather than, or fabric comfort by design rather than by guesswork. So how to translate human perception of comfort into objective means of characterizing textile products? How can somebody, by watching the TV, the computer, or clicking on a button, get to feel the fabric and feel how comfortable the fabric is? And by the way, there is a portion of the screen in the bottom that is raised. I guess we're going to have to live with this throughout the whole presentation. But what I meant to write on the bottom here is creating a virtual intimacy with the product. Now, people in the food industry, believe it or not, have done a job, or a better job than we did, because now there are some foods that you can go to the internet and buy it, and you can almost taste it. So we've learned a great deal from what the food industry did in this regard. We have to understand one thing that many of us seem to misunderstand, that is, human is not a thinking machine. We are not made to be a thinking machine. We are rather a feeling machine that can think. So before we think about anything, we have to feel it. We have to be emotionally involved in our thinking process. So how can we convert different human feelings, human perception of fabric into something that's objective, something the spinner and the weaver and the garment maker can understand, instead of saying it's too harsh, it's too soft, it's too edgy, all of these descriptions? How can we convert these into design parameters that we can use? Now, the perception of comfort. Well, there have been extensive research over the years on comfort. You probably heard the term handle. Went back and looked at some of the dictionaries, and handle is defined as to try or examine as by touching or feeling or moving with hands. And that's an instantaneous feeling. As soon as you touch the fabric, you very much can make or pass a judgment on that. The eyesight, most of the surveys that were done on handling were involved a lot of outliers and problems because of the fact that the eyesight is affected. People, as they look at the color and they look at the appearance of the fabric, they often use this as part of their judgment of the fabric handling. So it's not a pure judgment, and we certainly cannot isolate this from that. And that's what I put together as I called it, eye handling. There is no way that I can continue with this. I'm missing a big portion of this. And if I cannot cheat, I'm not going to be able to read everything I have here. So let me just try. I have to admit this is the lousest conference I've ever been in terms of organization, preparation, you name it. Whether this is going to work or not, I have no idea. I'm just going to try. A little bit, okay? Comfort, on the other hand, is defined as a satisfying or enjoyable experience. Now, notice the difference between these definitions. When we talk about comfort, we are talking about experience, not instantaneous judgment based on touch and feel. You have to wear it. You have to wear the garment in order to feel it and in order to actually pass an objective judgment of how comfortable it is. So we can use an eye handle instead of the common term handle as a human initial perception of fabric or clothing feel and appearance. But comfort itself is a very objective concept. It has nothing to do with subjectivity. Obviously, the way we reflect our feeling about comfort can be translated into very objective means, such as the neurophysiological and the thermophysiological factors of comfort. The comfort psychology is also another factor. Depending on your mood, you may be judging things. We did a survey a few years ago asking them, we did not give them a piece of fabric and ask them how they feel about the fabric. We generally asked them general questions about how they feel about fabric comfort in general. How do you perceive clothing comfort? 37% of responses was complete unawareness of clothing. 48% of the responses was good protection. If you catch somebody doing physical activities, running or jogging or performing some sports, the immediate response is that he is or she is fighting against the fabric they are wearing. They much rather be naked. If you're catching somebody in the warm weather, you want a fabric that provides cooling. If you want to catch somebody in the cold weather, you want a fabric that provides protection from the environment. The other question was about experience for some time with the clothing you are wearing. What is the primary fabric-related factors that you would consider in relation to comfort? That was an 18,000 people response, and it was an internet questionnaire. 58% of the responses were interaction with the skin. 31% of the response was protection. And you can see the similarity of the two answers. Other comments were nude-like protective clothing, clothing that does not fight me as I walk or run, skin-friendly, clothing that I can only feel when I wish to, and all of you, as soon as you get home, the first thing you do, you take off your shoes and you take off your clothing. The whole idea of clothing here is protection. And if you look at the good old days, people used to walk naked or half naked or partial naked. So the unawareness of the clothing that you are wearing is a key factor in providing comfort. There are many work that was done over the years on comfort. Most work has involved empirical evaluation of existing fabrics. Some has involved evaluating new fibers. Many involve measurements of basic comfort-related aspects, the FAST system, the better system. Hess here has developed some methods to measure fabric comfort. And many involve classic analysis, regression, or neural network, or fuzzy logic. But there is one thing that is missing in common in all of the studies that we have seen, and that is a structural model of fabric comfort. We need to model the phenomena. We cannot test phenomena that we cannot define. You cannot claim that your system measures comfort if you don't know what comfort is. So we have to start from basics again, and we have to do the fundamental. Is it 5 minutes? Why do we need a structured comfort model? Number one, to simplify the characterization of human response to comfort. Took me 5 minutes to explain as well. And number two, to provide meaningful combinations of values of comfort-related parameters. We have to provide the designers, the fabric makers, the garment makers with some useful parameters of comfort. So we have to objectively characterize fabric comfort, and we have to do comfort by design. This whole project was inspired by Roger Milligan. Many of you may know him, many of you may not know him. He's perhaps the head of textile business in the US, who simply challenged all of us. If everybody can go to the store and define comfort, we should be able to. We should be able to provide a simple index that can characterize comfort. So we searched for simple way to describe comfort, and we started with the state of comfort based on the survey that we did. And the two basic ideas here is the state at which the fabric has a minimum interaction with the skin, and it has an optimum positive interaction with the environment, which in this case is the surrounding media and the localized against skin media. The first aspect deal with the thermophysiological, and the second one deal with the neurophysiological aspect of comfort. Here are the neurophysiological aspects, and I guess I just have to show the slide without saying anything. Here are the thermophysiological comfort factors. And the structural model has to fulfill many criteria. It has to account for all external physical activities, from a relaxing mode to a very, very active mode, like sport or any type of physical activity. It has also to account for different environments. It has to account for different age and different genders, from a child who cannot express how he feels to older people that can very well describe what they're feeling. It has to account for extreme applications, because comfort for the fireman or the people in the military or people that are doing specialty work is extremely, extremely important. So the underlying assumption that we found was the key to define a common universal comfort definition or comfort concept is the area of contact between the skin and the fabric. In relation to neurophysiological comfort, the true area of fabric-skin contact can affect the interactive modes between the skin and the fabric, all these factors. In relation to thermophysiological comfort, the true area of contact governs the transfer of heat, moisture, and air. When you wake up in the morning, if you have a carpet in your bedroom, you go into your bathroom, if one foot is in the carpet, the other foot within the bathroom tile, you feel different, right? One is cold, the other one is warm. The area of contact is the same, at least the apparent area of contact. But the true area of contact is what's making the difference between cool and warm. So we use this to save time here. The people in thermophysiologists normally define the apparent area of contact between the skin and the body using the so-called gauze area. That's based on the weight and the height or the length of a human being. They can give you an estimate of the area, the apparent area. That's assuming a normal body. As you all know, bodies these days are not very normal. What they call it skinny, to me, is not so skinny. We see a lot of obese people. In fact, the standard size today need major change because they no longer apply. So what we use in here, we use in body scan as a way to obtain the apparent area of contact. But we also have to deal with the true fabric area of contact, that is the microscopic and the macroscopic area of contact, and we use an image analysis to achieve that. The relationship between the fabric and the skin is a deformational relationship. Both the fabric and the skin are viscoelastic in nature. And what an analogy there. Because using this relationship, you can easily define the pressure area relationship. This is the model, just to make the story short. This is the true area of contact, this is the apparent area of contact. And the factors in this model, without getting into the theory here, are the pressure distribution, the surface hardness, and the surface roughness, and the skin pressure. We can then extend this model into the different elements of the model. If I look at the surface hardness, there is no one side from the other. There is a fuzzy area in the middle at which the surface hardness is an optimal value, or a value that can provide optimum level. For the designer of garments, factors that will affect the surface hardness are fiber attributes, such as the lateral compression of the behavior fiber, we studied that, the fiber type. As you go to the yarn, we have the yarn attributes, the yarn type, and bulkiness, and the fineness of fiber. As we go to the fabric type, and the fabric attributes, such as thickness and bulkiness. The garment type as well. As we go to the asperities, or the surface roughness, again, we have extreme values at which the human body is totally in discomfort shape, but there is an area in the middle that provides comfort where the surface roughness is optimal. And again, factors such as surface morphology, cross-section shape, yarn surface structure, packing density, surface irregularity, fabric attributes such as design, fabric design, other factor, pore size, all these are factors that can affect the surface roughness of the fabric. That's how the model evolved, getting all the design parameters into the model. We can also express the surface roughness of the fabric in terms of the conductivity or the thermal conductivity of the fabric, the number of fibers, which brings about the fiber times as a factor, the fiber length. So you can see that we're going down to the fiber and the fiber attributes. And that's how the model look about this modification. I'm almost finished. And then we can take the fabric thickness in relation to pressure and develop the model even further. To make my story short, we have major project. Any help that we can get will be welcome. Any participant that would like to share will be welcome. And as I mentioned earlier, I'm not gonna, I can't talk about this. Time is up. So I'm gonna have to conclude with that this work is in progress. We really have an outstanding team. And if there is any company in Egypt that would like to join us, we are not asking for money. As I said, we have a $1.2 million. We really don't know what to do with the money. What we really need is an industrial partner. And by industrial partner, I mean people that are willing to follow our design criteria, make the fabric, send it to us, we will test it and give you the feedback, and it will be a win-win situation. Thank you.
It was remiss of me, in fact, not to give you an opportunity to give a round of applause to Jimmy Lamb for the first paper. Whilst the next speaker is preparing the presentation, have we got one or two questions maybe? You can use the microphone.
Dr. Mogahzy, my compliments to you on this work. I hope you would know that I'm working in this field too.
You are?
Yes, on hand. Love the head snow.
That's a shame because I'm the leader of this project and I don't know that you are.
I can't be involved because Krishna is trying to help me out because...
Oh, I have to mention that Mr. Dr. Krishna is here who's a partner, and I didn't know that you'd be here, but I mentioned...
because Tech is not a part of NTC, so we tried this time.
You're welcome anytime.
The thing is, I do compliment on the work, and you have mentioned about the surface roughness to be a critical factor in the hand. I think the friction, which goes back to your work with Bob Gupta, where you characterize the friction as a viscoelastic parameter depending on the load and the apparent area or true area. You haven't brought the concept of friction.
Well, you said Bob Gupta, and that's a big mistake. But that was my PhD. So it's Bob Gupta and Mogahzy. So the work on friction is my work.
Yeah.
And the reason I did not bring up friction is very simple. I don't have time. In fact, all the experimental results that I glanced through very fast are all friction analysis. But friction is a part of it. Once you have pressure, and once you have area of contact, then by nature, you have friction as a part of that.
So that's what my query was. The component of friction would be a principal component rather than other. Thank you.
It is normal.
I think we have just one more question in the back. Do you want to use the microphone?
Thank you. My name is Mohammed Saad, head of Textile Engineering Department, National Research Center, Cairo. Thanks, Dr. Mogahzy, for your presentation. And my question is, will it be possible to have a figure for comfortability on the label?
This is the whole idea. The whole idea is not just provided design parameter. Eventually, you're going to have on the label, not just the cotton polyester blend, 50-50 or 60-40. You're going to have a comfort index. In fact, what I showed here is a simple index from 0 to 1. The question here, who's willing to put the label?
This will affect the purchasing of course.
Of course.
You tell the consumer to buy or not to buy, okay?
It's already happening. In buying windows, for example, there's an insulation, the R number, where you can buy the window from the internet for any price depending on the R number. You will have different options, and that will be a cost.
One final last question. What do you use the microphone?
Who the hands still out of the fire?
I'm Dr. Abdelhady. And my question is whether it is possible to put in the equation of comfort other factors like psychological status due to fashion and also social status of the person as well. Do you think we can do something like that?
I wish I had 3 hours to talk about this model. But if you notice in the very beginning, I said what are the factors that the model should account for. And I mentioned physical activities, I mentioned the environment. The whole model stemmed from psychological survey, by the way. Because we asked the people first, what do you think of comfort? So the whole model, and by the way, no matter what you do with the structural model, there is no way to verify this model without going back to the people. The people in different environments, different psychological modes, different physical activities are the only judge, which makes the job very tough. Because no matter what we do in the laboratory, unless the people approve what we do, it's not going to mean anything.
So this means that this includes also social status.
What we're going to do is $1.2 million.
We seem to, David, have you got the technology going, or have we got one more question?
We're still booting up here, and this is not yet coming through. So
Okay, one more question until we can get the technology going.
I'm lucky to have it.
Sorry about that.
I have 2 small questions. The first is the positive interaction to the environment. And the second is, why don't you develop comfort scale?
Yeah.
Not index, scale.
Yeah, well, it is a scale. However, the index comes from the scale. If you notice, I showed the scale, and unfortunately I didn't have the time to talk about it. When we use the area ratio, there are 2 extremes of area ratio. The true area of contact versus the apparent area of contact. First of all, you don't want to be naked. And naked means an area ratio of 0. Okay? Nobody wants to be naked everywhere under any environment. The other extreme is an area ratio of 1, which means you are wearing a garment that's adheres to your body, glued to your body, and that's the other extreme. So that's the scale that you mentioned. But the label, the index itself, will be an identity of the fabric that you wear. What type of fabric and at what point of the scale this fabric will be. Yeah, that's what it is. It came from a scale. It came from a scale, from 0 to 1.
I think also you have to differentiate between inner wear and outer wear.
Oh, of course. Oh, definitely. As a matter of fact, a low comfort value or a high comfort value will depend on all of them. The type of fabric, the type of environment. If you wear the fabric for fireman, most important thing is fire protection. So the fireman is going to have to give up some of the comfort side, okay? Because protection to him will be more important than comfort. So we have a team, by the way, I failed to mention. Not only that we have professors such as Dr. Krishna and other people, we have just about everybody can imagine, including medical doctors, including physiologists. It's a very large team that covers just about everybody from the psychological side, from the scientific side to, we also have an industrial partner, 2 of the biggest sportswear companies in the world that are working with us.
Any more questions? We're struggling a little bit with the technology at the moment.
What? I'm using mine? Because I can tell you.
No, it was loaded up. It was all ready, but somebody turned this off. Somebody turned this off, and then we can't find it again.
Any other questions?
Any final questions? Okay, well I think on behalf of all of us I would like to thank our speaker for a very stimulating presentation. In spite of everything.